Okay, today we're going to cover notes number 7, the characteristics of a quadratic function. So today you will be able to identify the characteristics of a quadratic function. Okay, so we're going to talk about the different parts of quadratic functions today and what they each represent. So let's kind of review our linear, quadratic, and exponential. So I'm going to start by drawing my graph. Okay, our linear, if you remember, is a straight line. Our exponent is 1, our parent function is y equals x. Our quadratic is our U shape with the vertex going through the origin, if I can get it right on. There we go. So if you guys remember, our parent function is y equals x squared. That exponent is the 2. And our exponential is that sideways L, as I call it. So it grazes the x-axis and then goes up. And this one, the parent function is y equals 2 to the x power. And that exponent is that x. So let's kind of review those three. We've gone over those multiple times. So now we're going to go down and talk about our quadratic parent function. So like we said in the beginning, our parent function is y equals x squared. So in talking and graphing this, we're going to enter our table. Our x's are -2, -1, 0, 1, and 2. So if we were to plug our x in for our x value right here, we would get our y value. Or you could also put it into your calculator and get your table. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So if you guys see, it goes from 4 down to 0 and then back up to 4. So that's how we know it's a quadratic. It makes that U shape. So let's graph these. We have -2, 4, -1, 1, 0, 0. Oh, they're kind of off on that one. 1, 1, and 2, 4. And then we're going to graph our quadratic function. Okay, now let's talk about the parts. So our vertex is going to be this, either it's going to be the bottommost point or the topmost point of our function. So our vertex is going to be the top or bottom point. And we're always going to write it as an ordered pair. So this vertex is 0, 0. Now our next thing we do, is it a max or a min? So we look at our vertex. Is it the maximum value or is it the minimum value? So this one, our vertex is at the bottom. So it's going to be our minimum. So it's a min of 0 because it's at my 0 on my y-axis at x equals 0. So our statement for this, it's going to be a min or max of my y value at my vertex at x equals, which is going to be your x value at your vertex. So keep that in mind, and it's going to be the same pretty much every time. Your axis of symmetry is your x value at your vertex, or we like to call it it's this imaginary line that goes down the middle. So it's going to be your x. So for this one, it's going to be x equals 0. So it is your middle x value. I'm going to call it. Okay, now our domain, if you guys remember from last year, is our x value. So this graph is going to continuously keep going up, so it's going to hit all of our x values. So this is my x value. So since it's going to hit all my x values, I'm going to call this all real numbers. So you can also write this all real numbers. And then our y, this one, it starts at 0 and goes up. So our range is going to be our y value. It's going to be y is greater than or equal to 0 because it starts at 0 and it goes up. Okay, let's go down to our next function. So this one has a negative sign in front of it, so keep that in mind. So compared to these two functions, number one, it got flipped. That's what happens when we have a negative in front. And then you had it shifted over and up. So that's what happens whenever you have the +2 and the +4. It'll shift it around. So our vertex, we're going to hit first. This is going to be our topmost point on this one since it's the highest. It's going to be either the bottom or the top. Or it's also another way to put it is where it changes direction. So this one's vertex is going to be -2, 4. And that vertex is its maximum value. So that vertex is its max, and then it just is lower than that. So it's a max of my y, so max of 4. That's my maximum y value at x equals -2. Now your axis of symmetry is this imaginary line down the middle at your x value, so that would be -2. So we're going to have x equals -2. Our domain, as we said before, because that x that keeps going on and on and on, is all real numbers. And our domain, since it's at 4 or goes lower, it's going to be y is less than or equal to 4. Okay, so if you have any questions over the first page, let us know. So these characteristics are going to be really important, and we're going to keep going over them. Okay, the back problem, we're going to hit a couple word problems. So this first one says, identify the key characteristics of a bouncy ball that a student tried to bounce in Mrs. Mariani's room. So if we look at this, our bouncy ball started down here. So this would be 0, 0. And all the way across the room, and it ended at 5 feet. So this would be 5, 0. So we have to think, okay, it went up 3 feet. So what is that point? So over, it would halfway in between 0 and 5, it's going to be 2.5. So it's going to be 2.5, comma 3, because y is our height. So let's go over and identify our vertex. 2.5, comma 3, we identify that as the max height and how far the ball was at that height. This is a max since it's at that vertex is at the very top. So it's going to be a max of 3, because it's max 3 feet high at where my x is, which is 2.5. Axis of symmetry is that middle line, that imaginary middle line down the middle. So that would be at x equals 2.5. Now, our domain and range could become a little bit different because can a bouncy ball go a negative number of feet? No. So we have to think, what was our bouncy ball in between? So on the x, it went in between 0 and 5. So our domain is going to be 0 is less than or equal to x, which is less than or equal to 5. This is saying that x is less than or equal to 5, and it's greater than or equal to 0. So it's in between those boundaries. Now our y value, it started at 0, and it went all the way up to this 3. So that means our y value is in between 0 and 3. So we're going to write this similarly. So we're going to have 0 is less than or equal to y, which is less than or equal to 3. Okay, so in our next problem, we're going to have to draw our picture. So it says the kicker for the Capital City Cavaliers football team starts the game by sending the football a maximum height of 25 yards. So that's going to be our y value because it's the height after flying a horizontal distance of 60 yards. So after it flew 60 yards, it had a maximum height of 25. And then it started at 0, 0. So we're going to start. It says, assuming the football is kicked at 0, 0, sketch a picture of the football and identify the key characteristics. So we're going to start by drawing our picture. And this ball went up and back down. Well, my computer just glitched. Up and back down. So let me carry this line on. Oh, goodness. Okay. So it started at 0, 0. Sorry, you guys, I'm having some issues here. So this point right here is 0, 0. Now, it reached a maximum height of 25 after going a distance of 60. So, our vertex is going to be 60, 25. Now, we have to think, so how far did it go total? So we have to double that, and it would be 120. So this would be 120, 0 at this point over here. So now you have to go identify what's our vertex, our max and our min, statement, axis symmetry, our domain, and range. So the vertex we've already identified as 60, 25. And looking at this, is it our max or min? It's the topmost, the maximum point. It's not a min, it's our max. So it's going to be a max of 25, because that's the max of my y value, at my x equals 60. Axis of symmetry is that imaginary line, which would be the 60. So it's going to be x equals 60. Now, our domain and our range. So our domain falls in between our 0 and our 120. So it's going to be 0 is less than or equal to x, which is less than or equal to 120. Our y falls in between the 0 and the 25, because that's our y value. So we're going to have 0 is less than or equal to y, which is less than or equal to 25. So vertex is 60, 25. Max or min, it's our max. Our axis of symmetry is that imaginary line, which is at x equals 60. Our domain is our x value, so it ranges between 0 and 120, because that's how far the ball went. And then the maximum height was 25. Okay, last problem is review. First up, we have to combine like terms. So we get negative 6x minus 8 is less than 16. Add the 8 to both sides. We get negative 6x is less than 24. And then divide by negative 6. Since we divide by negative, we have to flip that inequality sign. Number line, I have 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. This is going to be an open circle because of that inequality sign. Now I have to figure out which way to shade. I plug in 0 for x. Is 0 greater than negative 4? Yes. So that means I'm going to shade where 0 is, because it is a solution. Okay, if you have any questions, let me know.